Okay, so last time we talked about the concept of a linear equation. One of the things that we talked about is that a linear equation, the variable is raised to the first power. The meaning behind this is that it keeps the equation from being something a little complicated, like a square root or an absolute value, or maybe even a higher exponent on something that causes some curves to happen in the graph. Because linear equations, by definition, make a line. And that's what we're going to look at today. We're going to actually look at what does a linear graph look like and how do you get that picture. One of the first things that we're going to focus in on has to deal with the last node on this page. We talked about also last time that a linear equation has a very specific pattern. When you start plugging in numbers for x, every time x increases by 1, you have a very specific pattern for the y values. This is called the slope, or the change in y over the change in x. Rise over run. We're going to actually see that physically happen today when we start looking at an input-output table. Because one of the best ways to graph any function that you ever deal with is by making a table of values, plugging in some numbers for x, and getting some values for y. Now, we reviewed that a little bit in the function introduction video, but it's going to be something that you see in this video and in our other lesson videos where we graph quadratics and exponential functions as well. A table of values gives you multiple points to connect the dots and draw a line in this case, or a curve in those other graphs. So what we're going to do first is we are going to learn how to get a function into what we call function form. In other words, we're going to rewrite the equation, and all three of these are linear, so that y is a function of x. Now look right here very closely. Y is the key here. That tells me that I'm trying to get y equals something with x over here, and we talked about that in our function introduction video. So a function of x is some expression with x, some multiplication, addition, subtraction, division, whatever it is, something that we do to x to get the y value, something that we do to the input to get the output. And so what you do to do that is you take these equations and you isolate the y by itself. So in 2x plus y equals 10, you subtract the 2x because it's a positive 2x from both sides. When you do that, it cancels out here, leaves me with y equals 10 minus 2x is literally 10 minus 2x. You cannot actually subtract those. So be careful when you're putting something in function form. Don't do too much with the x's and the y's. Now technically, when we were talking about last time, the slope-intercept form of a linear equation, you could switch this around to negative 2x and plus 10 if you want to start thinking about your m and your b like we did last time. Remember, we talked about how linear equations have that beginning amount and what it's moving by. In other words, it starts at 10 and it goes down to over 1 for my slope. So we're going to talk about that. That's going to also be a way that we graph later on. So let's practice this again. Let's take number 2. We're going to subtract 6x because it's a positive 6x. That gives me this canceling out, negative 3y, negative 3 minus 6x over here. Then I've got this number beside y. So this is where we want to divide because it's negative 3 times y. The opposite of multiplication is division because negative 3 divided by negative 3 is y because it's 1 when it cancels out. Now when we say that cancels out, we don't really mean to 0. We mean that it's actually just dividing evenly to 1. Same thing over here. Negative 3 divided by negative 3 is 1. Negative 6 divided by negative 3 is a positive 2x. So you could also write that as 2x plus 1, mx plus b. It's the same thing that we talked about last time. So the difference is today I'm giving you the equations versus you're having to actually write them on your own. So make sure you pause the video here and try number 3 on your own real quick before I go through it. Now that you've tried it, you should be able to take and subtract 4x, subtract 4x. You get 2y because this cancels. Negative 2 minus 4x. We divide by 2, divide by 2. We get y equals negative 2 divided by 2 is negative 1. Negative 4 divided by 2 is negative 2x. Again, you can switch it around. You're not required to. But this right here is my slope-intercept form. Slope-intercept form is basically the same thing that we talk about when we say function form. Now, when we get into some of the other functions we'll learn throughout the year, and throughout this course, I should say, you will see that y equals is the big key that makes something function form. For linear equations, y equals mx plus b is the same thing as slope-intercept form, but it's the same thing as getting something into function form. Because here's what we can do with it. If we can get that y by itself, we can get it into function form, then we can choose some values of x and make a table of values. Meaning if we can get it to y equals mx plus b, then we can take and make a table of values by picking some numbers to plug in for x. Typically, negative 2, negative 1, 0, 1, and 2 are good numbers to plug in. And we plug it in to whatever the function is to get our y values over here. We do the math, kind of like that function machine I talked about in the first little function introduction video. We do the math with x, and we get the y. Then, that's going to give us points to plot on a graph. And so these points connect in a straight line for linear equations, curves for other functions that we'll learn. So if we can get the y by itself, we can make a table of values and plot the points, connect the dots. So you may want to write these notes down if you want to. These are kind of the steps that we're going to use to graph first. Then we're going to learn a couple quicker ways to graph. Before we do that, I hinted at this in the last video that I made, but I want to make sure I drive this home. The whole reason that we learn how to graph is not because it's just fun to do. Remember last time we ended by talking about a fundraiser of t-shirts and hats to make a certain amount of money, and we said this x and this y that we find an answer for, the way that we find it is by making it into a graph. Because the graph is literally a bunch of points that are the solution. So you may want to also copy this down. The graph of an equation in two variables, sorry I missed that line a little bit there, is the set of all solutions that make the equation true. Another way of saying that is this. When we graph, every point on the line or every point on a curve is a solution to the equation that we are graphing. So if we graph one of these three equations we started with, we are going to see a big group of points, even the ones that are on the line past the ones that are in our table, will be solutions to the equation. And so that's the reason that we graph. We graph because the graph is a set of all the solutions. It's not just for fun. It's not just because Mr. Harrison thinks lines are pretty. It's because every point on the line is a solution to the equation. So we're going to go through a couple of examples using this kind of longer method of making a table of values. And then I'm going to use a couple of quicker ways of graphing with a couple special points. And we're going to go back to that slope-intercept form again. Then I'm going to also take a look at a couple special lines called vertical lines and horizontal lines. All right, so our first method of graphing is what I was talking about a minute ago, where we solve this for y. We get y by itself into function form. So we subtract this 2 because it's a positive 2, not because subtraction is the only thing we do. I know the examples that we looked at have had some subtraction in a lot of spots, but it's because this is a plus 2 to cancel it out. 3x minus 2, you can't really do. You can only write it as 3x minus 2 because they're not like terms. Then what we do is we're going to make a table of values. We're going to plug in -2 for x, -1 for x, 0 for x, 1 for x, and 2 for x. Now, one of the things I told you that we were going to talk about is how 3x minus 2, it's 3 times x minus 2, is going to give me the y value. But it's also going to show me that pattern that we were talking about of the slope, the rise over run, or the change in y over change in x. So we're going to look at that and notice that when we go through this table. So we're going to multiply 3 times -2 minus 2. 3 times -1 minus 2. 3 times 0 minus 2. At this point, some of you may be saying, well, Mr. Harrison, do I really have to write that middle column every single time? No, I'm not going to require you to. But it does help you kind of plan out what you're typing into the calculator. Or it does help you see that a function does the same thing over and over. That's kind of the definition of what a function is. You take the same pattern, the same thing that you're doing to x every time. So 3 times -2 is -6, minus 2 is -8. 3 times -1 is -3, -3 minus 2 is -5. 3 times 0 is 0, 0 minus 2 is -2. Then you would keep going. 3 times 1 is 3, 3 minus 2 is 1, 3 times 2 is 6, 6 minus 2 is 4. But I also noticed this, and this is a shortcut that you can use because if you know it's a line, you're going to see this happen. What do I mean? Notice it goes up 3 when x goes over 1. Up 3 over 1. Up 3 over 1. Sorry, guys. Up 3 over 1. Now, some of you may be thinking, okay, I get it, Mr. Harrison. I got it the first time. Guys, I'm trying to make you see that this is that whole concept we talked about of the slope being rise over run, up 3 over 1. Because right here, that's the m. The slope is 3. So when we go to our graph over here, we're going to graph this point, -2 and -8 for y. -2 for x, -8 for y. -1, -5 is -1 for x, -5 for y. But notice what it did, up 3 over 1. 0, -2 is 0 for x, -2 for y. Notice that's the place where the graph crosses the y-axis. We talked about that a little bit already, but we're going to do more detail here in a second. That's the y-intercept, the place where it crosses the y-axis. Notice the x value is 0, and the y value is -2, just like we see with our b value, because that's the y-intercept. That's why this is called slope-intercept form. So 1, 1 is right for x1 and up for y is 1. 2, 4 is 2 for x and 4 for y. Notice that makes a straight line because of the slope. It's up 3 over 1, up 3 over 1, up 3 over 1. But here's the key. The whole reason, like I said, for graphing is that this is a solution. This is a solution. This is a solution. This is a solution. Even the decimal points that are in between two numbers are solutions, even though that's not pretty answers. These little decimal answers in between are still solutions that make y plus 2 equal to 3 times x. So whenever we graph, we're finding the answers that work. So like I said, if we wanted to find the answers for x and for y for this t-shirt and hat fundraiser we talked about, we would graph this equation. This one would be a little bit uglier because there's pretty big numbers here. That's why I'm going to teach you another way for a couple little shortcuts of graphing. But we could find the x's and the y's would be a bunch of points on the line that work to make me get the right amount of money. And it works the same way even if we're not talking about money. So when we graph a line, we're finding all the solutions. So notice if I said, is 0, 0 a solution? Goodness gracious. There we go. Is 0, 0 a solution? Well, you could plug in 0 for y, plug in 0 for x, and you would find out that 2 equals nothing. That's not true. But you could also look at the line. It doesn't touch 0, 0. Then I could ask you, okay, is 3, 7 a solution? Well, to see if 3, 7 is a solution, if you plug in 3 for x and 7 for y, that'd be 9 equals 9. It is a solution. But look at the line. Why is that true? Because 3, 7 is on the line. Guys, every point on a line is a solution. That's the reason we graph. So, be prepared to make some table of values and find some points on a graph when you get to your quizzes and your final exam as well. So let's take a look at another one of these. Let's do another table of values here. Let's see. Let me find one that I like. Where did it go? Wow. Never mind. I thought I had one that I liked. Oh, yeah. That's going to be good. We'll just use this one, I guess, since I can't find the one that I thought I had. All right. So 2x minus y equals negative 2. So first thing we're going to do is we're going to solve this for y. So we're going to subtract 2x like we did before. If we do that, that's going to be negative y. And it's going to be negative 2 minus 2x. Then we want to divide by negative 1 in front of this y. Basically to get it to disappear, but also to give us y equals our function form. Negative 2 divided by negative 1 is a positive 2. Negative 2 divided by negative 1 is another positive 2x. Now what I can do is I can use my table of values here, and I can plug in numbers for x. Negative 2, negative 1, 0, 1, and 2. 2 plus 2 times x. Notice on this one I didn't switch it around, but that's okay if you did. So I'm going to do 2 plus 2 times negative 2. 2 plus 2 times negative 1. 2 plus 2 times 0. And I'm going to stop there because I'm going to use my pattern once I figure out the fact that my m, remember, is 2. My slope is 2. I'm thinking that I should see this thing going up 2 every time we go over 1. Let's see. So 2 plus 2 times negative 2 is negative 4. So 2 plus negative 4 is negative 2. 2 times negative 1 is negative 2. So 2 plus negative 2 is 0. 2 times 0 is 0. 2 plus 0 is 2. Notice it's going up 2, over 1, over 1. So this is going to go up to 4 and up to 6. Guys, that's the beauty of linear equations. You can find the pattern, which is called the slope, and you can plot those points and connect the dots as well to find your line. All right, let me zoom in on this guy a little bit here. Might have zoomed in a little too much. That's a little better. So negative 2 is here. Oh, come on, pen. There we go. Negative 1, 0. 0, 2, 1, 4, and 2, 6. Notice, I'm going to point out a couple things because this is about to be our topic of conversation. Notice that the line has the same pattern the whole time. So technically, to draw a line, all I really need is 2 points. I don't really need 5. But every single point on the line is a solution. So when I'm looking at this equation, 2x minus y equals -2, every single one of these points, if I plug them into here, will give me -2. That's the whole point. Yes, pun intended. That's the whole point of graphing, is that the points on the line are solutions. The other thing I want to point out is because you only need 2 points to graph a line, we are going to talk specifically about the points that touch the x-axis and the points that touch the y-axis now. The x-intercept and the y-intercept. Because those 2 points give me another way to graph a linear equation. So the table of values is really important. Please don't forget how to make a table of values. You've probably done that numerous times before, but in particular for linear equations, look for that pattern. When we get into quadratics and exponential functions, we're still going to be making tables of values, so it's a very important skill. But there's also a couple of quick ways to graph. One of those is looking at the intercepts. The x-intercept is the point where the graph crosses the x-axis. On the x-axis, the y value anywhere on this axis, the y value is always 0. A y-intercept is the point where the graph crosses the y-axis. Anywhere on the y-axis, the x value is always 0. So if you can find the point where the graph crosses the x-axis, it's going to have a y value of 0. If you can find the point where the graph crosses the y-axis, it's going to have an x value of 0. So what we can do is we can kind of work through that backwards. In other words, we can take our equation where we had to usually make this ugly table, make a bunch of points, and we can just find those 2 special points by plugging in 0 for the opposite variable. In other words, if we want to find the x-intercept, we plug in 0 for y. If we want to find the y-intercept, we plug in 0 for x. You probably want to copy this down right here. That's pretty important because that's how you find those 2 quick points on the graph. After you pause that and copy that down, make sure you copy down the equation as well. 2x plus 3y equals 6. So, just a minute ago, what we did is we took that 2x plus 3y equals 6, and we subtracted the 2x. We divided by 3. 6 divided by 3 is 2. -2 divided by 3 is actually -2/3. Ooh, that's a little uglier. I got a fraction. This right here is my slope, like we talked about. This is my y-intercept. Oh, we're going to talk about that in a second. But this right here is my slope-intercept form. And we also made a table of values for that. But when you get fractions like this, that's not always efficient. It's not always pretty either. So one other way of graphing is to leave the equation in this form. This is technically called standard form of a linear equation. And we find the x-intercept and we find the y-intercept of that graph, because all you really need to make a line is 2 points. So we can find those 2 special points by doing this. To find the x-intercept, we let y equal 0. Now I say let y equal 0. You could say plug in 0 for y, whatever. You are literally going to your equation and plugging in 0 where the y is.
3 times 0 is nothing, so that is 2x equals 6. And so what you're left with is a very simple equation. 2 times x equals 6. If you divide by 2, you get x is 3. Now here's where Mr. Harrison's going to be a bit of a jerk math teacher here. You need to understand that this is not just 3, but it is 3 for x. What did I plug in for y? That's right, 0. So it is not just a random number. It is a 3 and a 0. It is a point on the graph. Specifically, it's a point that is going to help me make this line here in a minute. And it's also a solution to the equation. That's the whole reason for graphing, guys. So y-intercept is the same concept, but the y-axis always has an x value of 0. So for the y-intercept, we plug in 0 for x. Now that's a more common feeling of plugging in 0 for x than it is for plugging in 0 for y. But it's the same concept, because when you plug in 0 for x, this cancels out to 0 and leaves me with another simple equation, 3y equals 6. We divide by 3, and y is equal to 2. But again, I'm going to be a jerk math teacher here. You need to know that that means that the x value you plugged in was 0. The y value was 2. That is a point on the graph, 0, 2. That is not just like we did over here when we solved for y to get a table. The table is using this equation right here to get a bunch of points. The y-intercept is only one point on the graph, and the x-intercept is only one point on the graph. But if you have both of them, you now have the line that connects the dots. And that's just using some maybe kindergarten skills there. Now, again, let me zoom in here, show you something. Remember what we said about graphing. The whole point for graphing is that not only are these two solutions to the equation, points on the line, but so is this one. And I know my line's just a little bit off. And so is this one. Every single point on this line, let's use this one right here, for example, -3, 4. If you plug in -3 for x, 4 for y, you're gonna get 6. That's the whole point. Graphing gives me a bunch of points that are solutions to the equation. So I keep going back to this example, but that's how you would find solutions to these ugly real-life problems. If you graph it, every point on the line is an answer. So let's do another quick graph using this concept of x and y intercept. So the x and y intercept for this particular example, 3.5x plus 7y equals 14. So if I want to find the x and y intercept for that one, let me zoom in a little bit here. The x-intercept, what did we say? We said the y value is always 0. So we plug in 0 for y. Oh goodness, sorry guys. That gives me 3.5x equals 14. I divide by 3.5, and I get x is equal to 4. Again, I'm told you here I'm going to be a jerk math teacher. You need to know that that's not just a 4, that it's actually a point 4, 0. Now the 4 may be the important part of that point because it's the only value that's not 0. But you need to understand that it's 4, 0. So when you go to the graph, let me scoot this guy up a little bit here. I say I was going to scoot it up, but I guess I'm not. Okay, never mind. 4, 0 is the point right here on the graph at 4. Now I see what's going on. The pen is acting crazy on me. Hey, there we go. Let's see if it'll slide up now. There we go. Gotta love technology, right? 40 is right here. Oh, it's going to do it again. Oh, goodness. Sorry, guys. Sometimes technology loves you. Sometimes it doesn't. There we go. 40 is here. It's not just 4. It's 40. But the 4 is going to be probably the most important thing. We're talking about kind of a real life context. And I'll show you what I mean by that in just a minute. All right. Now, we want to get the y-intercept. So the y-intercept, same concept, but now we're on the y-axis. So the x value is 0. So we plug in 0 for x. And then we're going to find the y-intercept. So we divide by 7, and we get y is equal to 2, or 0, 2. That is my y-intercept. Again, the whole purpose is, now we have a linear equation that matches those points. And it is the line for this equation equal to 14. So every single point, even the ones that we didn't graph, every single point on this line is a solution to the equation. So the whole reason for doing these methods of graphing is to get the solutions. All right, so that's using our x-intercept and y-intercept. The x-intercept and y-intercept would be a really good way to graph one of these, even though the numbers would still be pretty big. Now, what we're going to take a look at now is another quick way to graph. This way is using what we call the slope-intercept form. Oh, that sounds familiar. Oh yeah, that's because that's what we did the other day when we were first writing linear equations. Sometimes your y is already solved. Sometimes you solve it for y because you're going to make a table of values. Other times you solve it for y because this m and this b are going to help me out a lot. Here's why. The m and the b give me a nice, quick way for graphing. The m, like we said the other day, is the slope. The b, like we said the other day, is the y-intercept. Wait a minute. Why does that matter, Mr. Harrison? Because look at what you have. The y-intercept is a point on the graph. And I even joked about this a little bit. It's where you begin with word problems. Guess what? You can do it with graphing too. You can begin your graph at the y-intercept. Then I kind of joked a little bit too. I said, guys, in a word problem, the slope is how you move across the graph because of the m, to help you remember that. It tells you how you rise over run. But in real life, it also tells you how something like we did our population of California is moving. So when you have slope-intercept form, you have a point where the graph begins. Again, I'll make an emphasis on that, where your graph begins. And you have a rise over run, or what your graph is moving across the graph. So guess what? If you know where it begins and you know where it moves to, you can draw the line. Let me show you. Let's say we have y equals 3/2 x plus 2. The b value is 2, or 0, 2, the y-intercept. The m, the slope, is 3/2, or rise over run. That means my line is going up 3 over 2. Up 3 over 2.
look at what I just did. I just got a graph of my linear equation across there. And now I have a bunch of solutions to my equation. This is perhaps the quickest way of graphing a slanted line, because if you can find the b value, like on this one, -3, you can go down to -3, put a point. Your slope is -1/2, so you go down 1 over 2. Down 1 over 2. Notice my line is -1/2, so it's going down across the graph. But now I have my line and I have a bunch of solutions to the equation. It's probably the quickest way to graph. The only thing that's bad about it is if your equation is not solved for y, you are going to have to solve it for y. You're going to have to add 2x to get this to 6y, and it'll be 2x minus 24, or -24 plus 2x. You're going to have to divide by 6 and get y equals 2 divided by 6 is 1/3. -24 divided by 6 is -4. Guys, again, use your calculator if you can't do it in your head. Then you begin your graph at -4. You move up 1 over 3. Up 1 over 3. You've got your line. So, particularly for me, it's my favorite method of graphing. A line, anyways. But some people don't like it because you still have to sometimes solve for y. Sometimes they like to do the intercepts better, because on that one, you don't have to solve it for y. You just have to plug in 0 and get x. Plug in 0 for x and get y. It makes it a little easier than doing this whole thing here. But either way, you can get the equation of the line. You can get the solutions by graphing it across the graph. Our final thing that I'm going to cover today, and I know I've said a few things that are our final. This is the last thing, sorry. Our final thing we're really going to cover today are horizontal and vertical lines. Horizontal lines are ordered pairs where the y value is the same the whole time. In other words, -3, 2 is here, 0, 2 is here, 1, 2 is here, 2, 2 is here, 4, 2 is here. Notice the y value is the same the whole time. That means the equation would be y equals 2 the whole time. That is called a horizontal line because that line would go straight across like the horizon. Anytime you have y only in an equation, this is called a constant function. It basically means the value for the whole thing is constant the whole time. It doesn't have an mx, so it doesn't have a slope. It's zero slope is technically what that is. So, the same thing can happen with x. You could have -3, -4. -3, -4 is a little bit down here. Sorry, it's in the middle of my yellow box here. -3, 0. -3, 1. -3, 4. Notice that makes a vertical line. But notice that the x is the same the whole time. That is when you have x equals -3. That is a vertical line straight up and down across the graph that hits those points that are all -3 for x. So these two lines, when you have only x's, those are vertical. When you have only y's, those are horizontal. If it has an x and a y in it, that's that y equals mx plus b. That is the slanted lines. So if you ever run across vertical and horizontal lines, they're not extremely common in real life. All you have to do is look at it and say y equals -5. That means the y value is -5 the whole time across the graph. And so all I've got to do is be able to count down to -5. And I'm not going to be able to get this perfect here, but
down to -5 and put a horizontal line. When you see something that is only an x equals 5 tells me x is 5 the whole time across the graph. If that's the case, then you only have to draw a line at 5 by counting to 5 and putting a vertical line. So horizontal lines only have y equals. Vertical lines only have x equals. And they're really quick lines to graph. They're just not very common in a bunch of real life situations. But on your picture that you're drawing for your linear equations picture project, you might want to use some of those vertical and horizontal lines because they'll be easy equations. Y equals a number for horizontal. X equals a number for vertical. Make sure you practice your problems on graphing. If you got any questions, don't hesitate to send me a message and let me know.